Hello students, welcome to Sources classes. Our today's topic will be integral transforms. So let us start with our first sum. So here is our first sum. It says find the Fourier sine and cosine transforms of fx equal to 1 for x belongs to 0 to a and 0 for x is greater than a. So let us first find our sine transform. So this will be fs s equal to integration from 0 to a. This will be sine of sx dx. So integrating this easily we can get minus of cos sx divided by s, and the limits here are from 0 to a. So putting the limits we directly get our value, that is 1 minus cos of as divided by s. So this is our sine transform, and now let's find our cosine transform. So this will be fcs equal to integration over 0 to a. Here we have cos of sx dx. So integrating this we simply get sine of sx by s. So now putting the limits here we have from 0 to a. So putting limits here we will get sine of sa by s. So this is our sine transform of the equation, and this will be our cosine transform. So now let's move on to our second question. Okay, so here is our second question. It says solve the integral equation, which is integration over 0 to infinity fx cos lambda x dx equal to e to the power minus lambda. So here we need f of x equal to, so we know it is multiplied by 2 by pi, and in integration we have from 0 to infinity it will be e to the power minus lambda and cos lambda x d lambda. So here we have 2 by pi, and this is a simple integration which can be found easily by parts, using by parts. So in by parts, cos lambda x will be our first term and e to the power minus lambda will be our second term. So solving this and putting this value from 0 to infinity, we will get our value. So I'm writing here directly the value obtained by integration. It will be 1 by 1 plus x square. So basically this is our solution to the integral equation. So now let's move on to our third question, which is the last question here. Okay, so this is our third question. It says solve the fx, the integral equation, and the integration is from 0 to infinity fx sine tx dx equal to 1 for t belongs to 0 to 1 and 2 for t belongs to 1 to 2 and 0 for 2 greater than equal to 2. So let us find the function fx. So here we have fx equal to, so here also we have 2 by pi, then integration from 0 to infinity, then we have function x of t which multiplied by sine of tx dt. So putting the functions here we will get 2 by pi, in bracket we have integration from 0 to 1 and sine tx, and in second we have 2. So this will be from integration from 1 to 2, from 1 to 2. Here we have 2 sine tx dt. So solving this integration we get here 2 by pi. Now solving the integrations here we get minus cos of tx by x, and our limits are from 0 to 1, plus the second one will be minus of 2 cos of dx by x, and the powers are from 1 to 2. So putting these values in our equation here we will get okay, so it will be 2 by pi. So let us write here 2 by pi, and putting these values here we get 1 minus cos of x by x, and second will be plus minus of 2 cos 2x plus cos x into 2 by x. So further solving this equation here our final value will be 2 by pi x, and in bracket we will have 1 plus cos x minus of 2 cos 2x. So this is our fx. So we have our answer to the third question.